Hi ESS folks, it's Miss Lenorovitz, and in this video I'm going to walk you through the final step of putting together your enlarged carbon model. At this point, your carbon model should have all of the reservoirs and forms of carbon, as well as the different processes that move carbon from one place to the next. The very last step that you're going to be doing in your model is actually adding fluxes, so giving a representation of exactly how much carbon is moving in each direction. So we're going to go through how to do that. So first, you're going to want your large carbon model back again. I know that it's gotten very busy and you're going to have a lot of stuff on it, and I'll talk you through those remaining steps. All right, folks, so your model should look something like this one now, probably with a little bit more detail than what's shown up on the screen. So yours obviously will also include the reservoirs, like the atmosphere, which would be labeled here in this diagram. You also have many more fast and slow carbon processes represented in yours. So in this model, we're going to zoom in and just take a look at the process of burning, which takes carbon that's stored as starches and sugars in plants and transforms it into carbon dioxide. In your model, of course, you probably have another green arrow that is fast carbon that's representing burning from fossil fuels in factories, also leading towards carbon dioxide in the atmosphere. So the next step is to add a little bit more information to this arrow to show the flux, or the amount of carbon that is transported through that process. So how are you going to do that? One of the things that you're going to need in order to do that is this document that you've been working with previously. So the last time you were using this document, you were identifying each process, whether it was fast carbon or slow carbon, and you were exploring its explanation. So you were looking at the source of that carbon, where it ends up, and then the process that it ends up going through. So that's how you added those arrows to your diagram. What you're going to add next is how much carbon it adds or removes from the atmosphere. So we're going to look at where you'll get this information about the flux. So I'm going to look specifically for burning in this example. What you're going to need is your carbon cycle understanding fluxes between carbon reservoirs. So you need to have finished this activity in order to do this next step. Once you find that packet, which you are going to bring to you for your next class as a CA, you want to turn to part 3 of that packet. And when you get to part 3, it looks like this. You're going to see a table here where you were looking at processes and annual fluxes. You'll notice on the left-hand side here, we see combustion of fossil fuels. That's the same thing as burning, so this particular one happens to represent for fossil fuels. This process adds more carbon to the atmosphere. In fact, it adds approximately 9 gigatons of carbon, or 9 billion tons of carbon every year. So I'm going to use this value right here to go add that information into the chart we were just looking at a moment ago. So on this chart, I would go ahead for burning, which is also known as combustion, and I would write down here that 9 gigatons of carbon per year. I'm going to follow the same step for each one of these other processes. For any of the processes where that last column is filled in with gray, you don't need to record a value. So it's only going to be the boxes that are filled in white right now. So you're going to gather that information, and once you've done that, you're going to translate that onto your model. So now I'm going to go ahead and represent that last piece that we did, representing the amount of carbon that is entering the atmosphere from burning. So I have an arrow here going from our factories that are combusting fossil fuels to the carbon dioxide in the atmosphere, and I've labeled that burning as adding 9 gigatons of carbon per year. And that's happening in more than one place on our diagram. It also happens if we combust wood and plants as a forest fire might, and that same process is going to be adding a total combined of 9 gigatons of carbon per year. So hopefully that gives you an idea of what you're going to do next. Again, you're going to be adding those fluxes as labels to your arrows. Good luck, and I look forward to seeing your finished product.